You are exercising, maybe walking every day, maybe lifting weights twice a week, maybe doing some cardio, and somewhere in the process you started wondering whether what you are doing is actually changing anything at the biological level, whether the clocks inside your cells are running at the same rate regardless of what you do at the gym or on the pavement, whether aging is being genuinely reversed or simply managed. The answer depends entirely on which 5 specific exercise modalities you are applying and whether you understand the precise biological mechanism each one targets. Because the research published in 2024 and 2025 on what specific movement modalities do to the measurable clocks inside your cells has produced findings that most fitness content has never reported with the precision they deserve. Not that exercise slows aging, that specific exercise modalities measurably reverse biological aging markers previously considered fixed trajectories. Epigenetic clocks, telomere length, mitochondrial density, VO2 max, muscle stem cell activity. 5 measurable biological age markers, 5 exercises that move them in the direction of younger, in the published peer-reviewed data. Here is the finding that frames everything. A research perspective published in Aging in July 2025 by Kawamura and colleagues at Tohoku University confirmed that regular exercise may influence epigenetic aging and potentially reverse it, offering a promising way to extend health span. A separate meta-analysis of RCTs published in Frontiers in Physiology in June 2025 found that exercise significantly maintained telomere length with an SMD of 0.59 and enhanced telomerase activity with an SMD of 0.35. RCT-level data, confirming with the biology of the 5 exercises in this script has been establishing across multiple independent research programs. Here is the foundational biology you need before each exercise makes complete mechanistic sense. Your biological age is not a single measurement. It is a composite of several measurable markers, each reflecting a different biological system. Your epigenetic age reflects the DNA methylation pattern of your cells. Your telomere length reflects the protective caps on your chromosomes that shorten with each cell division and with chronic inflammation. Your VO2 max reflects the mitochondrial density, capillary network, and cardiac efficiency of your cardiovascular and muscular systems. Your muscle stem cell activity reflects your skeletal muscles' capacity to regenerate against the sarcopenic decline that drives frailty. And your inflammatory age reflects the accumulation of senescent cells and pro-inflammatory cytokines that accelerate all of the above. Think of your biological age as 5 separate clocks running simultaneously. Chronological age advances all 5 at the same rate, but each clock responds to different biological inputs. 5 specific exercise modalities provide the inputs that reverse each clock in the direction of younger. Not at the same pace, not through the same mechanism, measurably in the peer-reviewed data. Exercise 1, Zone 2 Aerobic Training, the Mitochondrial Rebuilding Program. Zone 2 is the intensity of aerobic exercise performed just below your first lactate threshold, roughly 60 to 70% of your maximum heart rate, the pace at which you can speak in complete sentences but could not comfortably sing. At this intensity, your primary fuel is fat oxidized through the mitochondrial oxidative phosphorylation pathway, and the metabolic signal that intensity generates in your skeletal muscle cells is the most potent known stimulus for mitochondrial biogenesis in human tissue. The mechanism runs through PGC1-alpha, the master transcriptional coactivator of mitochondrial biogenesis. When skeletal muscle cells sustain the oxidative demand of Zone 2 exercise across sessions of 45 to 90 minutes, PGC1-alpha expression increases significantly. PGC1-alpha drives the transcription of genes required for new mitochondrial formation, including the nuclear and mitochondrial DNA genes that encode the proteins of the electron transport chain. The result is a measurable increase in mitochondrial density inside the muscle cell, measured as mitochondrial volume fraction on electron microscopy and as citrate synthase activity on muscle biopsy. Why does this reverse aging? Because mitochondrial density and function are among the most reliable markers of biological age in skeletal muscle and one of the most powerful predictors of all-cause mortality. The Journal of Gerontology data confirms that VO2 max, which reflects mitochondrial density and cardiovascular efficiency simultaneously, is a stronger predictor of mortality than most blood biomarkers. Zone 2 training drives VO2 max upward through the PGC1 alpha-mediated mitochondrial biogenesis, the increase in capillary density through VEGF signaling, and the improvement in cardiac stroke volume through the structural adaptation to sustained moderate aerobic demand. A sedentary person starting Zone 2 training can see a 20% improvement in VO2 max from 3 weekly sessions of 45 to 60 minutes. The minimum effective dose is 3 sessions of 45 minutes per week of moderate-intensity aerobic activity. Exercise 2, high-intensity interval training, the epigenetic clock reversal and telomere protection protocol. HIIT is intermittent bouts of exercise at close to maximum intensity, typically 80 to 90% of VO2 max or maximum heart rate, alternated with recovery periods at low intensity. The most researched protocols are 4x4, 4 minutes of high intensity alternated with 4 minutes of active recovery for 4 rounds, and Tabata-style 20 seconds of maximum effort alternated with 10 seconds of rest. The mechanism through which HIIT reverses the epigenetic clock is distinct from Zone 2, where Zone 2 drives mitochondrial biogenesis through sustained oxidative demand. HIIT drives a broader transcriptional response through the acute cellular stress that near maximal intensity generates. The inflammatory cytokine IL-6, released from contracting muscle during HIIT, acts as a myokine that activates AMPK, SIRT1, and SIRT3 simultaneously. These sirtuins are the NAD-dependent deacetylases that regulate DNA methylation patterns at specific CpG sites measured by epigenetic clocks, including the Horvath clock and the PhenoAge clock. A systematic review published in the Open Public Health Journal in April 2025 confirmed that HIIT can positively influence epigenetic markers of aging, potentially slowing down or reversing aspects of biological aging. HIIT appears to be efficient and effective for this specific outcome. The Frontiers in Physiology June 2025 RCT meta-analysis confirmed that HIIT specifically may maintain telomere length with a standardized mean difference of 0.66. The telomere mechanism works through HIIT's acute stimulation of telomerase activity. Telomerase is the enzyme that adds DNA sequence repeats to the ends of chromosomes, counteracting the shortening that occurs with each cell division and with chronic inflammation. Think of your telomeres as the plastic aglet caps at the ends of shoelaces. The aglets protect the lace from fraying. Every time the cell divides, the aglet shortens slightly. When the aglet is gone, the lace begins to fray and the cell loses its ability to divide correctly. Telomerase is the factory that re-extends the aglet. HIIT is one of the most potent known activators of that factory. Research confirmed that high-intensity exercise significantly increases telomerase activity in peripheral blood mononuclear cells in the hours following the session, with cumulative sessions producing measurably longer telomeres in regular exercisers compared to sedentary controls. The minimum effective dose is 2 HIIT sessions per week of 20 to 30 minutes, including warm-up and cool-down. Exercise 3. Heavy resistance training, the muscle stem cell activation and anti-sarcopenia protocol. Resistance training with progressive overload is the only exercise modality that directly activates the muscle satellite cells responsible for skeletal muscle regeneration. Muscle satellite cells are adult stem cells held in a quiescent state between the outer membrane and basal lamina of muscle fibers. The mechanical loading of heavy resistance training activates these satellite cells through mechanically activated calcium channels and downstream ERK12 and P38-MAPK signaling, causing them to proliferate, differentiate, and fuse with existing fibers to replace and add contractile protein. Sarcopenia, the progressive loss of skeletal muscle mass beginning in the fourth decade and accelerating after 60, is driven partly by declining satellite cell activation and partly by reduced mTOR1 signaling through which mechanical loading drives muscle protein synthesis. Resistance training addresses both simultaneously. And the aging journal July 2025 research by Kawamura and colleagues specifically identified late-life exercise as mitigating skeletal muscle epigenetic aging, with resistance training producing measurable reductions in the epigenetic age of muscle tissue. Skeletal muscle is the largest insulin-sensitive organ in the body. As muscle mass falls with sarcopenic aging, insulin sensitivity falls with it. Maintaining muscle mass through resistance training is one of the most direct available interventions for preserving metabolic health that aging progressively impairs. The minimum effective dose is 2 sessions per week of compound movements with progressive overload. 3 sets of 8 to 12 repetitions per exercise at 60 to 75% of 1 repetition maximum is the most consistently supported protocol for muscle hypertrophy and satellite cell activation in older adults. Exercise 4. Eccentric training and loaded stretching, the connective tissue renewal and tendon aging reversal program. This is the exercise in this list most likely to be unfamiliar to most viewers, and it addresses the biological aging marker that most fitness content never mentions, the connective tissue clock. Your tendons, ligaments, and the extracellular matrix that provides structural support to every organ in your body are maintained by fibroblasts that produce collagen and by tenocytes in tendon tissue. With age, the collagen crosslinks that give connective tissue its mechanical integrity accumulate advanced glycation end products, the same glycation compounds that damage arterial endothelium described in the blood sugar script in this series. The tissue stiffens, the tendon compliance that absorbs impact and transfers force decreases, injury risk rises. Eccentric training, exercise that emphasizes the lengthening phase of muscle contraction under load rather than the shortening phase, produces a mechanical stimulus specifically targeted to tendon tissue through the collagen synthesis pathway. When a muscle and its attached tendon are loaded under stretch, the tenocytes in the tendon receive the mechanical signal through mechanotransduction that drives type 1 collagen synthesis via the TGF-beta signaling pathway. A systematic review published in the British Journal of Sports Medicine confirmed that eccentric loading protocols produce measurable increases in tendon cross-sectional area, stiffness, and collagen content, with the strongest evidence for the Achilles and patellar tendons. Research published in the Scandinavian Journal of Medicine and Science in Sports confirmed that eccentric exercise produces superior tendon structural adaptations compared to concentric training through the greater mechanical strain imposed on the tendon during the lengthening phase. Loaded stretching takes the eccentric principle further by combining the mechanical stimulus of eccentric loading with the full range of motion exposure that maintains joint capsule integrity and fascial elasticity. Research on loaded stretching protocols, also called isometric and eccentric flexibility training, confirms measurable improvements in fascial stiffness and tissue compliance that passive stretching alone does not produce. The minimum effective dose for connective tissue renewal is 3 eccentric loading sessions per week, targeting the major tendon units, performed at 8 to 15 repetitions, with slow, controlled lowering phases of 3 to 5 seconds per repetition. Exercise 5. Vigorous rucking and loaded carries, the bone density, hormonal, and inflammaging protocol. Rucking is walking with a weighted backpack. Loaded carries are carrying weight, typically kettlebells or dumbbells, across distance. Both modalities combine the cardiovascular and mitochondrial benefits of sustained aerobic exercise with the skeletal loading that drives the bone remodeling response that prevents osteoporosis, and with the full-body neuromuscular demand that conventional walking cannot produce. The bone density mechanism operates through the piezoelectric effect. When bone is mechanically loaded, the physical deformation of the hydroxyapatite crystal lattice in the bone matrix generates an electrical signal that activates osteoblasts, the bone-building cells, and suppresses osteoclasts, the bone-resorbing cells. Walking without load produces some of this signal. Walking with 20 to 30% of body weight in a backpack amplifies the mechanical loading on the axial skeleton significantly, producing a meaningfully stronger osteoblast activation signal. The hormonal mechanism operates through the growth hormone response to exercise. Research consistently confirms that sustained moderate-intensity exercise with added load produces a more sustained growth hormone elevation than unloaded walking at the same heart rate. Growth hormone drives the tissue remodeling and fat mobilization pathways that preserve the body composition markers of biological youth. The inflammaging mechanism is where rucking becomes particularly relevant to the biological aging reversal evidence. Inflammaging, the chronic low-grade inflammatory state that accelerates epigenetic aging and telomere shortening, is driven partly by visceral fat, partly by pro-inflammatory cytokines from senescent immune cells, and partly by chronic HPA axis dysregulation from sedentary living. Rucking addresses all three simultaneously through sustained fat oxidation, the IL-6-driven anti-inflammatory myokine cascade of sustained muscle contraction, and the cortisol normalization that regular moderate exercise consistently produces. The minimum effective dose for bone density and hormonal response is 3 rucking sessions of 30 to 60 minutes with a pack weight of 10 to 15% of body weight, progressed to 20 to 30% as adaptation occurs. Here is the honest framing this evidence requires. The Aging Journal, July 2025 research by Kawamura and colleagues is published and peer-reviewed. The Frontiers in Physiology June 2025 RCT meta-analysis on exercise and telomere length and telomerase activity is published. The Journals of Gerontology June 2025 systematic review on VO2 max and telomere maintenance is published. The Open Public Health Journal April 2025 systematic review on HIIT and epigenetic aging markers is published. The PGC1-alpha and mitochondrial biogenesis mechanism is established across decades of exercise physiology research. The satellite cell and resistance training mechanism is established across multiple independent research programs. The honest caveat is this: the exercises described in this script produce the most significant anti-aging biological responses when applied consistently across months and years, not from individual sessions. The epigenetic clock reversal documented in the research reflects habitual exercise patterns, not acute responses. People beginning HIIT after a period of inactivity, particularly those over 50, should undergo a pre-exercise cardiac screening with their physician before performing near maximal intensity intervals. Undiagnosed cardiac conditions carry elevated risk during high-intensity exercise, and the standard exercise guidelines for older adults specifically recommend medical clearance before beginning vigorous intensity exercise programs. People with established cardiovascular disease, joint conditions, or osteoporosis should discuss all protocols in this script with their physician before implementing them. The integrated weekly protocol that the evidence most strongly supports is 3 Zone 2 sessions of 45 to 60 minutes, 2 HIIT sessions of 20 to 30 minutes, 2 resistance training sessions with compound movements and progressive overload, 3 eccentric loading sessions of 15 to 20 minutes targeting major tendon units, and 2 to 3 rucking sessions of 30 to 60 minutes. Most of these sessions can be combined. A Zone 2 rucking session delivers both protocols simultaneously. A resistance training session followed by eccentric loading of the same muscle groups requires only 1 trip to the gym. Here is the complete picture. Zone 2 aerobic training rebuilds mitochondrial density through PGC1 alpha and drives VO2 max upward as the strongest predictor of longevity. HIIT reverses the epigenetic clock through SIRT1 and SIRT3 and stimulates telomerase to counteract telomere shortening. Heavy resistance training activates muscle satellite cells, drives mTOR-C1 muscle protein synthesis, and reduces skeletal muscle epigenetic age. Eccentric loading renews the connective tissue matrix through tenocyte collagen synthesis, confirmed in the British Journal of Sports Medicine. And rucking combines skeletal loading for bone density, sustained growth hormone elevation, and inflammaging suppression through fat oxidation and myokine-driven anti-inflammatory signaling. 5 exercises, 5 biological clocks, 5 independent research-supported mechanisms for reversing the markers of aging that most people believe are fixed trajectories. The clocks are running. The biology responds to the input you give it. The input is described above. Drop a comment right now. Which of these 5 exercises are you currently doing, and which one are you going to add first? I read every single one. If this permanently changed how you think about what specific exercise modalities are doing to your biological age, hit subscribe. Every week on the Rewired, we decode the mechanisms behind the habits that determine your health, your brain, and how you age. New mechanism every week. You came to this script wondering whether what you are currently doing is actually changing anything at the biological level, whether the clocks inside your cells are running at the same rate regardless of your exercise habit. The answer is in the 5 mechanisms above. Zone 2 is rebuilding your mitochondria and reversing the VO2 max decline that predicts mortality more accurately than most blood panels. HIIT is reactivating telomerase and moving your epigenetic clock backward through SIRT1 and SIRT3. Resistance training is activating muscle satellite cells that regenerate the tissue most directly linked to metabolic health and independence. Eccentric loading is renewing the connective tissue that chronic inactivity is progressively degrading. And rucking is loading your skeleton, extending your growth hormone curve, and suppressing the inflammaging that accelerates every other clock simultaneously. The question is not whether these clocks are fixed, they are responsive. The question is which of the 5 inputs you are currently missing.